Concatenating data frames vertically and horizontally in Pandas. This lesson will help you master combining data frames using Pandas. You will learn by hands-on typing, merging data from realistic sources. Let us explore real-world use cases and unlock new possibilities with your data. Running the cell now. We will silence Pandas warnings. This keeps our notebook tidy. We import the warnings module. Import numpy as np. We set the random seed to 42 for reproducibility. We set Pandas warnings to not show. Running the cell now. This setup code prepares the environment by suppressing warnings and setting a random seed for reproducibility. Although it produces no visible output, these steps ensure that the data frame operations you'll perform next are consistent and your notebook stays clean. This foundation is important before you start concatenating data frames to focus on the core lesson without distractions. We prepare our data using the famous Titanic dataset. We import Pandas. We load the dataset from a reliable source on GitHub. We create a data frame with the Titanic data. We show its shape to check size. We peek at the first few rows for a preview. Running the cell now. This output shows the initial Titanic dataset with 891 rows and 12 columns, giving a sense of the data's scale and structure before any concatenation. Notably, the head preview includes key passenger details like survived, P-class, and age, which you'll later merge or stack with new data frames to enrich or expand this dataset. Understanding the shape and columns here is essential for correctly aligning data when concatenating vertically or horizontally. Why concatenation? Imagine you receive monthly Titanic passenger data as separate sheets. Or maybe you want to add more columns with new passenger info. Concatenation helps you stack tables together or join side by side. It is vital for data cleaning, tracking updates, and analysis. Running the cell now. Now we mimic separate datasets from different months. We make a data frame for January with the first 400 rows. We make a data frame for February with the rest of the data. We print the shape of the January set. We print the shape of the February set. Running the cell now. Here we see the Titanic dataset split into two parts, simulating separate monthly data files. Notice both data frames have the same 12 columns, but different row counts, 400 for January and for 91 for February, reflecting different passenger totals each month. This sets up for concatenation, where we'll stack these to combine all passenger data across months while preserving the shared columns. Let us merge both months together vertically. We use Pandas concat, axis equals 0, to stack one data frame below the other. We check that the final row count matches both months. Running the cell now. Here, the output shows that concatenating the January and February Titanic data vertically has combined their rows, resulting in 891 passengers and 12 columns. Notice how the row count grows, confirming that concat stack the datasets on top of each other, which is useful for merging monthly sheets into one table. This demonstrates how vertical concatenation helps consolidate data from multiple sources without losing columns. Try splitting and joining your own data frames for practice. When we concatenate, index numbers repeat or skip. We reset the index to create fresh, sequential row labels. We look at the top rows to confirm our index is fixed. Running the cell now. After concatenating the data vertically, resetting the index cleans up the row labels, making the table easier to navigate. Notice how the key columns like passenger ID, survived, and P-class align properly, maintaining consistent passenger data across the combined dataset. This step ensures your stacked tables behave like a single unified data frame, ready for further analysis. Vertical concatenation details. Vertical, row-wise, concatenation stacks data tables on top of each other. All columns must match or missing columns will get NaN values. This is helpful when combining multiple files or appending new records. Running the cell now. Let us try stacking data frames where one has an extra column. We create an age group column in the January data, classifying by age. We stack January and February data frames again. We look at name, age, and age group columns for the first rows. We do the same for the last rows, where age group is missing for February. Running the cell now. Here, the concatenated data frame stacks January and February data rows, but only January has the new age group column, so February's rows show none in that column. Notice how the first 5 rows have valid age group labels, while the last 5 rows from February lack them, illustrating how missing columns result in none after vertical concatenation. This highlights the importance of matching columns to avoid incomplete data when combining tables. Horizontal concatenation, column-wise. Next, let us see how to add extra columns that belong together. This is useful for joining details from 2 sources, like adding ticket or contact info for each passenger. Running the cell now. Create a comment describing the upcoming data frame creation for contact info. Initialize a new data frame to store contact information. Copy the passenger ID column from df_jan to the new data frame. Generate a list of contact emails based on passenger ID values as strings. Display the first 3 rows of the new contact_info data frame. Running the cell now. This output shows the first 3 rows of a new data frame created to hold alternative contact information, aligned by a passenger ID. Notice how each passenger ID matches a corresponding email in this contact column, demonstrating the intent to add related details side by side. This setup prepares for horizontal concatenation, where these columns can be joined with the original dataset. Add contact information columns to the original January data frame by concatenating them horizontally. Concatenate the reset index January data frame and contact_info data frame, without passenger ID, side by side. Display the first 3 rows of the combined data frame, showing name, age, and contact columns to check the result. Running the cell now. Here, we horizontally concatenated contact information columns to the January passenger data, effectively combining details side by side for each individual. Notice the new eContactor column aligns perfectly with the existing name and age columns, preserving row order and showing how additional related data can be merged column-wise. This demonstrates how to enrich a dataset by joining complementary information from separate sources. Be careful. Horizontal concat expects matching row order and counts. Here, we combine a contact subset and the regular data without resetting index. Notice extra NaN values or mismatches if rows do not line up. We print the top rows so you can see what can go wrong. Running the cell now. Notice that the contact column has values only for the first 10 passengers, while rows beyond that show NaN because the contact_info data frame was sliced to 10 rows without resetting the index. This mismatch in row indices caused by horizontal concatenation without aligning indexes leads to missing contact data for subsequent passengers. The key takeaway is to ensure indexes align or reset when concatenating data frames column-wise to avoid unintended NaNs. Common parameters and pitfalls. Axis equals 0, stack rows, default. Axis equals 1, stack columns. Ignore_index equals true, reset row labels. Join outer, union of columns, default for concat. Join inner, only columns or rows shared by all. Always check your index, shape, and column lineup after concatenation. Running the cell now. Let us make row numbers start fresh with ignore_index set to true. After stacking, the index is reordered from 0 upward. We print a sample of the index to see this. Running the cell now. The output shows that after vertically stacking the 2 data frames, df_jan and df_February, with ignore_index equals true, the resulting data frame's row indices have been reset to a continuous range from 0 to 7. This confirms that ignore_index equals true effectively creates fresh, sequential row labels instead of retaining the original indices, which is useful for avoiding duplicate or disjointed indexes when combining data. Inner join is useful to keep only columns present in both data frames. Select passenger ID, name, and age columns from the January data frame. Select passenger ID, name, and fare columns from the February data frame. Concatenate the two smaller data frames vertically, keeping only columns that appear in both. Print the first 3 rows of the joined data frame. Print the last 3 rows of the joined data frame. Running the cell now. This output shows the result of concatenating two smaller data frames row-wise, axis equals 0, using an inner join on columns, which means it kept only the columns common to both, passenger ID and a name. Notice that age and fare columns are excluded because they don't appear in both inputs, demonstrating how the join equals of inner parameter affects the combined data frame's shape. The ignore_index equals true resets the index to a continuous range from 0 to 890, as seen in the printed top and bottom rows. Here is a small merge demo for a hands-on project. We sample 10 passengers with ticket info. We also sample 10 passengers with their names and ages. We merge using Pandas merge rather than concat, using passenger ID as our shared key. We print the final merged result. Running the cell now. Here, the merge was performed on the passenger ID column using a left join to combine df_sample and df_ticket. Notice that all rows from df_sample are retained, but the ticket and cabin columns result in all nans because the sampled passengerids do not overlap between the two subsets. This highlights a common pitfall: merging on keys that don't have matching entries leads to missing data in the join columns. Challenge: practice problem. Suppose you have 2 data frames. One holds the first 5 passengers' names and ages. The other has their genders and fares. Challenge yourself: vertically stack both data frames, then horizontally join as well. What differences do you notice? Running the cell now. Let us solve the challenge. We take first 5 names and ages, call this A. We take first 5 sexes and fares, call this B. First, we stack A and B vertically, one after the other. Then we join A and B horizontally, pairing matching rows. We print both results. What differences stand out? We print both results. What differences stand out? Running the cell now. In this output, observe that the vertical concatenation stacks the 2 data frames on top of each other, resulting in many nans because the columns don't fully overlap. Names and ages fill the first part, and gender and fare fill the second. The horizontal concatenation aligns rows side by side, combining all columns by resetting indices, which keeps the same passenger's details matched correctly. This highlights how pd.concat behaves differently with axis equals 0 versus axis equals 1. This exercise demonstrates the importance of choosing the right concatenation axis depending on whether you want to combine by rows or columns. Have you tried both vertical and horizontal concatenation now? Let us know in the comments if you found anything surprising. Recap: concatenation basics. In this lesson, you practiced combining data frames using vertical and horizontal concatenation. You learned to split, append, and align tables, essential for real-world data work. Keep experimenting and double-check your index, shape, and columns as you merge. Next, try using concat on your own datasets. Running the cell now. Thanks for learning. If you found this helpful, subscribe to our channel for more Pandas coding tutorials. Type your favorite tip from this lesson in the comments below. Happy coding and see you in the next Jupyter lesson. Running the cell now.